Hi, welcome to the lab. So today I wanted to work on our regex parser, which is required for our scanner generator library. So basically, why do we actually need regular expressions or a parser for regular expressions? I would like to specify a specification for a scanner generator like follows. So, excuse me. I would like to add tokens and give them a name, give them a pattern which is expected to match. So that wants to play. Do you interrupt me again? No? Let's try. So I can either give it an exact pattern, which I call literal token, so a pattern which is matched literally, and I can also give it a regex token, where I can say regular expression to specify a pattern where the contents. Let's say it a little bit differently, where a concrete value is abstracted over by a pattern. So this pattern describes infinite many possible, let's say, possible values for the token. Yes, okay, sorry. But of course, in a limited pattern. And yeah, for example, to be able to add a regex token, I'm working on a regex parser, which basically just knows how to do a subset of regex. So I'm not going to support the whole thing, a whole standard yet. So, and for now, we're just iterating, and we just iterated on some unit tests and fixed some bugs. So currently I'm only running unit tests, which we introduced last time. And if, for example, I change a unit test, for example, let's just change this one. We just rerun. And then we get an error, and it basically says that, well, we had this and this expression, and this expression evaluate to this expression to this. So this string to this value, and basically we expected that this expression actually is this, but it was something else. But in this case, of course, just our test is invalid. So, and basically, I'm going to do test-driven development for the next feature. I think it's the prime candidate for this. So yeah, and today we can only pass single characters and some operations, or let's say operations or operators. So I think both is correct in this case. So we know how to pass alternatives, regular expressions. We know how to pass concatenation, which is actually not done by using an operator such as the pipe, which is used by expressing alternatives. But so the concatenation is just done by by writing juxtaposition by writing the letters next to each other. So, but now today, basically, I would like to give it a string like let's give it a class, and let's see what we actually would like to get here. So I would like to, let's just start simple. If I give it a single character, I would like to also get atom back. So, but now I already see a problem, since a class, basically a class is a big alternative. But I don't think I would like to expand it to a big alternative. So, for example, if I give A to Z, I don't want to generate a huge alternative with 26 different cases, where you basically have A or B, or C or D or E. I think this is quite stupid. So I think I will just extend atoms that they are implicitly an alternative of a, so that I can basically just, that I can store them a little bit more efficient. So let's see how we can do this. So let's peek how our atoms are defined, actually. So atoms, I see. So basically before they for a single character, but I think we already have a character set, which basically is an alternative of characters. So, and I can construct it out of a single character, but also from a range. So I think we will store them as character sets, our atoms for now. So let's just do this as a first change. So let's just put this here, and let's char set. And let's rename this to char set. Of course, this returns a character set, but we don't need to actually return it by value here. Just return it by reference for now. So, and of course I have to include it, and I'm really going to include it. So no forward declaration here. No. So I don't know. I always autocomplete to signal, but I'm really not going to use this. So signal, I think, is so let's just peek there. What is actually signal? So I think those are the signals, the OS signals. Let's just peek there and learn a thing or two. So so this is what I see to register signal handlers. I see where you can handle like zigzag, so the segmentation fault. So learn the thing. So let's just keep going. So let's just return this here and also fix the atom constructor. And the field is also called char set. And SCD move and char set. Okay. So I think now our printer doesn't work anymore. So let's see, what do we want to do here? So so let's just delegate printing. I see. So let's just delegate printing to our char set implementation. Let's just double check how this is printed. So char set. So I just removed code. Do we have a printer? We have a printer. So let's just double check that we actually, if we print a character, like, so here we already have some code to escape it, but I would like to reuse the, so let's jump back. Regex. So now my other cat is crying. I don't know what, so I think it's potentially, so until a few minutes ago, they were sleeping really, they were really nice girls and boys, and they slept, and now they want attention. Cutie, how are you doing? So let's see if, so I think we get a visitor. Huh? Okay, let's just go back to here. So I stole the include, which I'm just going to move here. I'm just going to, so how was this actually called? Escape, and I get a string back. So we are just abusing this. So I think we are just going to print this. But how does it actually work? So I think it prints everything between characters. So in this case, it prints like /u. So I remember. So it prints everything in every visible character as a character, and every non-printable character as a hexlet. So like /u as a hex character, like /u, let's say 220. So I have to move my little cat out of the way. Do we want to stay here? Just maybe lay down. You want to stay here? So I think I'm always going to print this, like this. So I don't need to special handle this anymore. So now everything should stay the same. So what is this problem here? So, yeah, I know what this problem is. So let me just go back to our tests. I would like to, well, let's just keep it here. So let's remove our new tests. First, I'm going to, so what is the problem here? So here, I'm giving it a character, but it needs an atom. So an atom now gets a char set. So I'm just constructing one in place here. Yes. Made some coffee. So let's see. I think it should work exactly the same. So since we only deal with single characters until now, so let's just commit it. And I didn't introduce a repo yet. So let's just do this as a separate commit. What a cute little patch. So let's just for a character set, char set, an atom instead of single chars. Okay, so but now I should be able to express something like this. So maybe let's print it. Let's just slap something in. Let's just keep it simple and let's just do AB for now, and then maybe A to C. So let's just work on those three cases for now. And of course, I think now it should actually fail, since I don't think we have support for character classes. I see. So it basically reads this literally as a concatenation. So I need special handling to turn this into a meta character. So I think we're just going straight in. So let's see. This is our regex parser, and a primary expression. This was previously just a single character. What is this? Does this include open parentheses? can be primary expression. So I think let's actually stare at the ASCII table. ASCII table. Yes, I accept cookies. So, like 91 and 93. Where are those? So we have until plus, but I think plus is here, and we what? Or did I include them or not? And closing. I see. Those are negated. Open parentheses plus up to plus are negated. Then minus open parentheses. Yeah, so I basically have to exclude those. Minus is 45. So from minus to capital C as that, I mean, of course. Ooh, wow. So then I have the open parentheses. And basically I would like to handle this. So open parentheses cannot be atoms. And closing parentheses let's handle this separately. So a backslash, a single backslash can be an atom. And that's also exclude closing parentheses. So basically all brackets. I think I was previously calling them open parentheses, open brackets, and braces just to differentiate them. But I think I mixed them. Today. So closing parentheses. Then from open flags to a pipe. So up to open braces. Open braces. Okay. So I think this should be it. So basically we explicitly exclude the brackets from being atoms, but include them from being primary expressions. So then everything should still work. So our predicate still works. But here, if it can be an atom, so it can't be an atom. Also, an atom is basically a character, a single character literal. So yeah, this is just the name of it. Then it is handled here. But now I can also pass of course, so parentheses are passed here. Let's just sneak in the code for handling character classes. So now I looked at the first character, Then I can advance the cursor. Now I'm pointing to the first character inside of my character class. I think. So what can come next? So I'm going to accept single characters, followed by potentially a minus. Yeah, and then I have to construct a range. So basically, I think what I have to do, let's construct a char set. So this one is empty, I think. So actually, is it possible to create an empty character class? And what does it mean? Let's just the regex tester. So if I construct an empty character class, okay, sure. So of course, so this is fine. Yeah, so an empty character class is not possible because yeah, it would just be epsilon, I think. Ah, it's just the token which accepts everything. No, nothing. So I think, yeah, well, let's just ignore empty special cases for now. So I think now we can just do something while we are not looking at the end of the class. Then we have to handle empty, and then we can basically advance here. So basically we do something until we hit a closing brace. No, closing bracket, then we skip it, and then we can construct our result. So I just return null pointer to remind me that I have to do something here. So now what are the cases? I expect a single character. Okay, so maybe I can sneak this code. Can I put this into a separate function which just returns a single character? I think I can. So let's see. Let's just, for this parse pattern, let's just return a character. But I think I'm not going to return a character. I have to propagate arrows somehow. So what I'm going to do, I think I'm just going to return a unsigned 64-bit integer. So and then yeah, let's just abuse a really big number here. So then I can maybe in the future return multi-byte characters, but I don't know how I would handle this. But this should work, of course. So let's just define a static arrow atom constant. I'm just going to numeric limits. It will just be max value. Then I can put this code let's just do assert and the atom peak. Since I require that we always are right in front of a atom when we call this, then I'm just going to move all of this code here. Of course, in this case, I have to return my error marker, and in this case, I can just return my correct atom. So what is the problem here? Yeah, okay, I see. So then I can basically, so here we check the predicate, which gets rechecked here, but in this case we crash. And we are just going to pass an atom. Let's just call this atom. And if our atom is an error, we're just going to propagate the error. We already printed it. Else, we're just going to use the value which we, so let's just write this a little bit different. Let's just explicitly construct our char set. So this one is a singleton char set. And let's just cast our character. So we define as a move. Okay, so this should build again. What is your problem? What? No, I don't want this. This is a cast C++. Oh, I see. Oh, I don't want this. Let's call it using the braces. Should be fine. So now I can recall, so I can reuse this method. So now let's see. While we are not at the end of our class, we're going to consume a single atom. So let's just call it atom, I guess. Pass a atom if our atom is the error, we just return. Else we saw a atom. So now, what are the possible cases? Let's call this one okay, let's just see. So now, if we saw one atom, we can then see another one, or we can see a minus. So I think I have to exclude minus inside parentheses. So let's deal with it when the problem actually arises. So we saw so now I have to. So this one advances our scanner, I think. Yeah, it advances. So then let's just say if the next character is a minus, then we are constructing a range. So in this case, so let's just call this current. And let's just read another one, which I call next. Naming is hard, I guess. So in this case, I would like to do something like follow. So of course, I have to handle our, so of course, we have to advance after we see our minus character. So then we get the next one. We error check it. In this case, I would like to modify our char set. I would like to do this operation on it. So I would like to do a current and next. I would like to define a operator type equal, which just sets all the booleans. So my camera was lagging, I think. I think we are back. So, and on. So then this iteration is finished. But else, so else it is also finished. So I think this should be it. So of course, I could also say a mutable operation. Let's do this, I think. I would like to set in this range to true. I think I would like to do this. Okay, so let's introduce this operation, char set. So I wanted to open it on the left side, but it doesn't want me to do this. So how this, yeah, I see. So basically our constructor does a similar operation. We're just iterating all the possible characters and setting if this range is set. I see. But this operation depends on the range. My operation does not on the range. Okay, let's just do something like void set character first. So I'm specifying them here using new 8s. Let's keep this tradition. Value. I think I'm not going to name this parameter. Do I also want to do something like this? I think so. So, and here I'm just going to do this. But using the value I get passed in. And I then can call set here using the Boolean given by this expression and this similar but not same. So I would like to max. So let's let's say something like this. I would like to start on this character, and I would like to maximize this first, this and first. We actually have to include algorithm for max. So, and of course, this is not defined for 2/8, I think. So this is I use 16. So, and we would like to end on the last. So, in here, I would like to do min. So basically, I restrict the range which we pass in by the actual range we are given here. So if you give a larger range, then we prefer yours. Else, so I think this operation isn't really necessary, since my indices are basically unsigned, but I think it helps reading. So, and then I have to iterate this range and set the value to this. So let's iterate from start to end, give it our new value. So this value. Sure. So now this operation should exist. At least it should exist. So then I can go back to our parser. So this one should work now. So else we're just going to repeat. So let's see what actually happens. I'm just going to remove the code I added until now. And let's see what the test actually says. By now I changed some things in my predicates as well, but let's just see what our thing said. So I get a parse error. Now that I can parse expected atom but got. Where does this message come from? This is not really correct. Yeah, so in this case, we're not only parsing atoms, we're parsing primary expression. So this is the best message, but it's better than parse error. It's better than expected atom but got. And we are not only parsing atoms in our method we are currently in. So this is better. Better error message, at least for me. So let's try this. Does our simple class parsing code work? Okay. I still get a parse error because I'm always returning null pointer C. So let's actually return a atom with our character set. Okay, now get something back, but printing it different. So I print the character. So I'm giving, I see what the problem is. So basically I'm specifying spaces here in the test, but our printer doesn't print them. So could change this, but I don't care at the moment. So, but why does it, so ranges work? I see. Otherwise I have to add the single character. So, like this. Okay, now it works. But now I think I can do this a little bit differently. Do I want to? Let's keep it like this. So now I can print simple classes. So, and of course I should also be able to print A to Z, A to C. And I think I'm not going to specify it here. I am just going to run our program and see what it returned me. Then I'm going to look if it works. And if so, I'm going to steal it. So didn't want to type this, but it seems correct. So from A to Z and from lowercase a to lowercase z. I'm just going to steal this and I'm inserting it here. So it didn't break really nice, but not the worst. So I hate that this code actually wasn't really. Let's mess with it a little bit. So can't it just print that here? I'm not going to mess with it. Stay. Why does it break the H? So just stay like this. Fine. Enough fighting with the formatter. Okay, simple character classes do work now. So let's print. Let's commit everything. So, okay, so but now let's see what actually happens if, what is this case? Okay, so if the class starts a minus, it is supported to pass a minus. So like this should be, so where's the slash, the minus? I would expect something like this, but of course I don't know on top of out of the top of my head where the minus character where it is. So let's see if this works. Okay, so yeah, so basically this is what I was talking about. I didn't know where the character is in the ASCII table. So it's ASCII representation. I didn't know, so I have to swap it. Now the test works. Basically, it's the same. Okay. So this works. So I don't have to do anything. But what happens if I'm doing an empty character class? I think currently I think I will let the parser handle it and handle it this error elsewhere. So the parser is just general, accepts it, and I will parse it externally. So it returns an empty atom. So I think this is fine for now. Parser accepts the empty character class. All be handled elsewhere. So let's just document what I decided. Let's remove the to-do. So I think I'm just going to amend it to the previous commit since I haven't pushed the thing yet, so no problem here. Hey, kitty cat. I just love how she knows her name. Come here. So there it is. So now let's see what our character class should also. Should we do a special mode for? So let's see what happens if I give it a simple slash. Is this supported in normal regular expression? I think it requires a escape. I have to escape it. So this is fine. This we already support. What if I give it a slash n, for example? Then I would also expect a slash n. So I think those simple cases work. So yeah, this works as I would like to. I don't need to do anything special, but I like to support negations. So let's see, if my character class negate. So basically, if you negate your character class, for example, like this, let's say I would like to make the negation of this regular expression. I just put a circumflex at the first character, and in this case, I would like to match every other character as the ones listed here. So the whole ASCII range, but all of the characters except the ones listed here. So let's do this. So to do this, we're just going to remember negate whether we should negate and we have to skip it, of course. And at the end, we're just going to negate our char set. So negate. Let's introduce char set negate. So let's steal some code from here to iterate through the whole range. And we are just going to set I to not get I. So get is not defined yet. So we're going to do so. Let's also remove braces here. So to get a character, so this one is const. Oh, that is basically contained, so I didn't remember how I called this. So negate just negates everything. So now the operation exists. Now I should be able to call it here. So let's test it, and of course let's do everything. So I think so I can specify characters like this as a ASCII value. So let's use this for testing. So if I give it a 0 and a, what is the maximal value? So let's see. Let's again stay at the ASCII table. Let's say I would like to do all digits. So until slash. Can I do this now? Let's just try it. So and then from colon to tilde. Colon it was colon to tilde. Does this work? Well, what a beautiful smiley. And of course this should match everything from 0 to 9. Oh no, I'm going to copy it from the print, from the test failure. So, but it should contain every digit from 0 to 9. This is what I'm expecting here. I see. Works. Oh. Why is this? So this is not really correct. I did not expect this. So this print is wrong. Really wrong. Oh. So, but it starts from 0 to 9. I can use it to fix my test. At least I can do this. Okay, sure. Let's see what. So I broke everything. Why did I break everything? Because I'm always negating. Whoops. So of course, only if we saw the where is it? Only if we saw the circumflex at the beginning. I actually don't know if this is also called circumflexum in English. I'm just just continuing to call it that way. But okay, so but this doesn't work. Why? parse atom. So let's see what actually happens. Parse this one. So let's just copy this one as a separate test case. The end, and let's just return for now. Let's just see what happens whenever we come here. So we are parsing a primary expression, and it is not an atom, so it is a character class because it starts with an open bracket. We advance our scanner, then we should see a circumflex, which we do, and we are skipping it. So now we are in front of the 0 terminator. Construct an empty char set. We are just going to parse atom. So we passed 0, which is correct, and we advanced. Now we see an minus, which we skip, and then we pass the slash, which is 47, which is correct. So then we set this range. Then we continue parsing. We don't see a closing parentheses. So we pass an atom, which is a 58. This is correct. 8, a colon. This is correct. Then we see a minus character. And next we should see a tilde, which is 126. Correct. So then we also set this in our character range. Let's just double check. Now basically everything, why is everything checked? Not correct. Yes, it is. Yeah, because I'm setting the negation of what I actually want. So everything is checked except some cases, the middle, which are the digits. Then everything is checked again till the end. Oh. Yeah, I see. So my character set is not really correct. So then we at the end, we advance. Negate was set to true, we negate, and this is where our character set magically gets values which I didn't expect previously. So since our last CIC, but basically to do this correctly, I have to give it much bigger max value. So let's just say FF. This should work now. So character sets are unsigned 8-bit numbers, and yeah, so I didn't set the values be greater than 126. This is why negating caused characters appear magically. So it should still work. We pass an atom from 0 to 47. Then from, I think this is the colon to 106. I changed the wrong test case. I'm running this code. Let's just try again. So character class, so the first case, the first range, fine. Second, now it passes as a error. Why? parse error. Why did it error out? Let's just put a breakpoint here and run again, and let's just skip 3 times. The first 3 are 0, slash, colon, and now we have to look. So we see a slash. Can we construct a string? So this one gets one too far. Oh, is it already one too late? Something is fishy here, so I'm constructing a. This is too big. This character view is too big. So I'm skipping the slash. So then I exactly at the U. So U, F, and F. So this is not correct, I think. So input.size. Input size is 50. 15 minus 11, 4. 4 in 3 is 3. It should be correct. But why? I see. So I just derped. So the string view, of course, contains more characters since since the C line doesn't know my string view. So yeah, it's perfectly fine. So then this gets unescaped. Let's jump there. So, and here basically we get our string view. So, and we are not empty. Our string view is not empty. And we see a U, and we are exactly 3. So we are not less than 3. So then we call unhex twice. So unhex. What does this one do? So we are looking if our character is between A and F, a lowercase and uppercase, and a digit. So this works. Then we are normalizing our character. This should now be lowercase. Lowercase is not between 0 and 9. It should be here. And then we return our value. And it is, of course, 15. This is correct, since F is the hexadecimal value of 15, and we return true. So then we have the first character. Then the second character is also a 15. Is result correct? So result prints as -1. So result is a character here. So I think this is the problem. Let's change this signature to actually return a U8. So in here, let's return so advanced returns a character. Let's explicitly say that we want a character, so then we use it here. This should work. So let's try again fine. Let's just run it, see what happens. So I think decoding the value was not correct. So let's skip 3 times. We had the colon, so 1 more. So now we see let's just see what we're looking at UFF. We're unescaping. We are unhexing. This one worked previously. We would like to advance 3 times once we return. This doesn't work since we are casting it here, but I think the value is correct now. So let's see what happens. We return true. We're advancing 3 times, and we're returning our character 255. And then, so pass atom. So here we can actually cast to U8 now, since our character set also works on U8. And I think this will work now. Every time I build, my camera lags. I haven't noticed this before. Good to know, I think. So what does it do? Doesn't work. Why doesn't it work? Please work. So let's see, where does it actually hang? Have we any context? Not really. So I think this one works. Plus EI. So I think, yeah, I see. So we wrap around. So yeah, I see. So the problem is that this range, if I plus I on 8 max, I wrap around and go forever. So I'm just going to advance this range here. And then, so this case, so this is a U16, this is fine. But now this range we are iterating over is typed U16, so it is bigger than U8 max value basically. So this actually did help. Let's double check that it actually works. So now our test works. Yeah! So negation also works. Let's re-enable. So did I already re-enable the other tests? Sure. So I think I can pass classes. This is beautiful. So this is the test case for classes and some type change. So negate. I'm just going to commit everything. Thing. Port parsing negated character classes. I saw a problem, so can I rename this one? This commit. I have a dirty working tree. Now I have to. Let's just. Dash it. Dash. Then I can rebase. So I accidentally printed a printing here. Just going to fix this. I wanted to say parsing. So no problem, I didn't push a thing yet, so I can still rename it. So let's see, reapply our stash. It's on stage, perfect. So now I think I should be fine. So let's rerun again. This worked like a charm. So, and actually we did not really need a lot of code. Just like, I mean, what is it? 260 to 290, like 30 lines of code for character classes. I take it, I think. So now I think we support enough regular expression that we can actually progress with generating non-deterministic finite automatons. I think this is what we will do this in the next video. So let's rewind a few videos back. So basically parsing regular expressions was some kind of a digression. I have a file here where I so I basically high level explained what we have to do. So this is what we did in the previous video. I just forgot to get off. So we are currently at this step of creating non-deterministic finite automatons, which I'm just going to call NFAs, out of our syntax specification. So for example, we internally we take each of these statements, each of those add calls, and turning the patterns into automatons. Yeah, and for the simple case, we are already done. But of course, we didn't do anything for our regular expressions since we didn't understand them yet. So this is what we actually wrote our parser for. Now that we have a syntax tree, and I think I'm leaking really badly. Everything our parser allocates, we are leaking. So I think we should add this to our to-do list. So regex parser. Let's say each instance of regex is leaked, is currently. I think, so maybe we should work on this now. Well, actually, I'm finished what I wanted to do, but let's work on this as well, since I have another hour. Let's just start at least. So basically, I would like to, so how do we actually allocate in our parser? Oh, and I didn't change our comment here. So let's just sneakily append, change our documentation. Let's do this as a separate commit. Update documentation of regex parser. So no sophisticated documentation, but well, let's just keep it simple for now. So I think I want to do something like this. So our regex parser just allocates using new, so just on the heap. So what I think I want to do something different. I would like to basically allocate memory from a bump allocator and just drop everything on the floor, but not when the parser gets destroyed. Then we are not allowed to nuke everything, release the memory. But we want to control it from the outside. So I think so a bump allocator, a simple arena allocator should be fine. So let's actually implement a arena. Let's model this, how we want to use it. But also we could do I think it's called slab allocator, since all of our regex objects, so they are not actually the same size. So let's use a arena for now. So I'm thinking we're just going to accept a core arena. And we would like to modify its state, so we take it as a const reference, and we're just remembering it here as a reference. Of course, now it cries, and I think I'm just going to include forward declared. Of course, now I have to implement our constructor. Just going to implement it really fast. Arena. And then going to move this function. So this function, where is it? Here is it. I think this one will move into our arena. Let's see, how did we use it? So arena. So I didn't import arena. So I think I'm going to include arena in our header. Just move this method to our header for now. And I'm just going to keep it using new. No, let's just model it completely. So I would like to do something like follows. So this one is not static anymore, and it accesses our arena, and it's just going to allocate, let's say, t bytes. So size of t bytes. So then I get back a pointer, and let's say assert for arena alloc returned null pointer. And then I'm just going to use placement new. So just giving it the location where it should create my instance. So, and of course, this operation is not supported. So I'm not going to forward declare this, but I'm going to implement a arena. So, but also, I think could also do move this to our arena. So let's do this. So I would like to do something like follows. So basically thinking I'm adding convenience methods. So like construct. I would like to construct an instance of type T and just forward everything which we get. So, and I learned that I here have to use perfect forwarding. So let's do this. So, and this should also already return a pointer of type t, which we are going to return directly. So I think I can simplify it to this. And of course, this isn't, so this class doesn't exist yet. We're going to do now. So let's introduce a new class, which we're just going, let's introduce a new header. So no, let's use a new class. We're just going to call arena. And we move it into our namespace, core. So let's see, then I would like to using core.arena so that I don't do prefix it everywhere. So I can then drop my prefix here and my prefix. Well, let's keep the prefix. I actually, in this case, I like it. For string view, I don't want to prefix everything, but let's prefix core arena. So, and basically, I would like to introduce this API. So let's introduce a method which I'm going to call, it should be templatized, of course, and I'm calling it construct. So it returns a pointer to t, I'm calling it construct, and it takes some variadic arguments, which we're just going to, how was the syntax? Like this. Construct, yeah, construct. So now this should actually compile. So, and I would like to do this in 2 steps. I would introduce a method called alloc, which takes in a size or takes, well, I can just drop this, I don't care. So, and of course, construct has to be implemented in the header. So we're just going to implement this here. So we're just going to call this method with t. So basically, pointer alloc. Let's allocate size of t bytes, and then we're just going to placement new. So ptr then let's just steal this. So, and then I also, of course, have to include a utility for std forward. In colon, let's just say pointer. Let's assert that we get back a null point, a valid thing. And then I, of course, have to also include cassert. So now this method has to be called. So, and I think I have to remember which blocks I return. So let's just do the following thing. So let's remember a list of blocks, a list. So we have a list of blocks. So what is a block? A block is a small struct which is just going to be a pointer to a memory, and a size or I think the size will be fixed. No, it won't. I will explain. And a capacity. Okay. So, and then we are just going to create a new block which is currently used. Basically, we're just always going to allocate this block, and when it's done, we're just going to remember it. So, and how this should work. So my camera is extremely laggy today, so I'm sorry for that, but I don't have anything to do right now. So, and basically we're going to create a constructor and a destructor for our arena. And what I'm going to do right now, I'm going to just stub out everything. So, and of course, our list also allocates, but let's reserve some space for our list so that basically our arena never allocates. So I can give it a capacity. So it has an initial capacity of 4. Would be fine. So let's give it a bigger initial capacity. So first allocates a place for 16 blocks. I think this should be fine. And let's also define a static auto default block size. Let's just call it size. It's private. So, and a block size should be, let's say, 16K. What does it actually? Let's just use the calculator. I'm not really perfect at calculating in my head since, well, and I'm too lazy. Now, let's allocate those many bytes at once. And this size will be relevant if one allocation requests more size than our default blocks, I think. So let's implement this. So our constructor is fine, and our destructor has to remove every block. So let's iterate through our blocks. And we're just going to free every block. And also, if our current block is not null, we're also going to free this. So this is the idea, I suppose, so that we just batch together some free calls. What's your problem? Condition is always false. Yeah, it is always false at the moment. Okay, so now if you want to allocate memory, we are going to basically do the following. If our current block, so basically we do something like this. If the size we requested is bigger or equal to our maximum size of a block, in this case we have to create a new block size. So the idea is that I create a new block where I just malloc memory. I'm mallocing size bytes. Size is size, and the capacity is also size. That's at least my idea. Now I can just append this block here to our list, and we're just going, well, I'm moving it, so I'm just remembering our memory, the pointer block.memory, and I'm just going to return the pointer. So in this case, we try to allocate blocks sizes in size, always blocks of the size 16K. But if a user returns a block, requests a block which is much bigger, we're just creating a special block for her. And remember that we allocated memory and we totally ignore our current block. So basically, then we can do something like this. So now we know that our size fits into a single block. And so basically, for example, user requests 30 bytes. And yeah, so then we should have enough space. So basically now we can do something like if our current block is non-null, then we can check if what did I do? If we have still enough space for size bytes, then we can just use the current block. So then current memory plus so capacity, how much fits into this block. So I have to check size. Yeah. So this is the pointer which we can return. And then of course we have to remember but why do I remember the capacity? Oh, this is wrong, I think. Yeah, it is wrong. So whenever the size we're requesting is less or equal to the current block's remaining space. The remaining space you calculate by subtracting the capacity by the block's size. Remaining bytes. And then we are just returning this pointer, but of course we have to increment. we have to remember that we gave out this many bytes, and we're just going to return pointer. So else it doesn't fit. So basically in this case we push the block. I see. So it doesn't work like this. So this block is a pointer. Should I just put it like this and always allocate? Let's keep it really simple. So we're just always, I think this will be a lot simpler, conceptually a lot simpler. So we ignore that we have a current block, and we are just going to assume. So this is special code for whenever we allocate a much bigger size. So this doesn't exist anymore. So our current block is basically m blocks size -1. And we always allocate this block. Yeah, let's do this. So let's say, and we of course have to remember pointers of our blocks. No, we can, no, we can't. Well, we can, but yeah, actually we can't. So let's just allocate a simple block. Let's do this. Allocate block with a size. Let's do this. And I think this can be static. So then we can basically put this there and just return our block. In this case, so what is actually what? So the capacity is the second. So size is empty at the beginning. We will just return our block here. So we get a block back from allocate block size. Then we are setting the size to size, remembering the memory. So this creates an empty block. Let's call this empty block. Well, now I have a beautiful typo. So we have a helper method which just constructs an empty block, and it didn't change for whatever reason. Does it build? Let's ignore it. So we create an empty block. We're setting its size to size. We are remembering the memory and moving it in blocks. Okay, this should be fine. So because now, just whenever we create a new arena, we always allocate the first block. So we can say create an empty block of size 16K, and we always move it into the internal list. So because then it is guaranteed that we always have one element, at least one element. Then we can do dot last here, which doesn't, this method doesn't exist yet. So then we always can just do something like this. So this block is all. So then we check if the size, if we have enough space. So this is the remaining space. The remaining space is bigger or equal to the requested size. And we are remembering the current blocks. We pointed to the first 3 byte, then we're advancing the cursor. This one. Okay. Current is not a pointer, it's a reference to a block. Then we are returning the pointer. This doesn't work, so I'm just inverting this. Then, so basically I have to do something like this. In this case, I have to push a new block and then do exactly the same code. So basically, if I'm inverting this, I'm just inverting this, always push a new block. So mblocks dot add, oh, that's inline call. I think I can just write it like this. Bit cleaner. So if I always push, then always this code would be fine. But of course, this I have to repeat this expression, and then I'm just going to line this here. So in this case, I'm always pushing a new block, then always allocating in the block. Since it can't, the request size is not absurdly big, but it also doesn't fit yet. So I think this should be it. So now let's see why it doesn't compile. Why doesn't it compile? I have to swap those. No, I don't. What actually happened? Ah, I'm missing a dot. Well, was not a really good error message, and of course this expression comes here. And of course I have to give it an arena here. So this is just perfect. It fits perfectly together. So here I'm constructing, so this is in my test code. If I parse, I'm constructing an arena here. So then I can just parse everything. Well, I can parse everything, and in this case, it turns my regex, my parsed regex into a string, either the error message if the parse failed, or, well, in the successful case, the string. And then, only then, if this stack gets destroyed, the arena gets destroyed. So I think it will work perfectly, just fit together. So in this case, everything is fine. Those pointers live long enough, since they only get destroyed if the arena gets destroyed. And we should get another compile error. So this one that I actually did not expect, but I think I forgot to add arena to my build file. So I don't know why this it got formatted so horribly. But let's say so let's just add it here. So, or should I just sort it? Let's sort it. Either formatting, so EFG. So I think this should be done. This should be sorted. String, string, string. Of course, builder comes. So I think this should be fine. So let's then just say formatter, string, string builder, string view. So okay, let's add this as a first commit. Up cmake lists of 4. So then I'm just going to add arena here. Arena and also the PPP file. So let's see what our problem is. So our list said that we would like to have a first and a last operator. So let's just add this. Reference last. And let's just add first two. And let's also do the non-const overloads for now, since we added first and last. And I'm just going to implement this, well, inline by just saying return how do I want to do this? Like this? Yeah, I think I'm just going to defer to the index operator. And I can just copy and paste this expression, and for this I have to do size -1. And of course, let's just say assert non-empty here. If I had to do this in all cases, it will look really horrible. But I think it looks better to get this assertion instead of the index doesn't exist. Oh well, let's just don't care. So of course I'm not using those, but I'm only using this, but I think it is really handy to, yeah, well, since core I plan to use it more than just here. I think it's fine to add all of those methods. So this can also be a separate commit. Of course, I have to change this error, have to look into this error. So introduce list first and last. So the methods are so simple, I don't really have to describe anything. So then let's see what this actually tries about. Yeah, so I know, but arithmetic on pointer to void. So what's the big deal? It is not a really big deal. So let's just cast it to a U8. Can I do my pointer arithmetic? Is there a warning if I just return this as a pointer to void? Capacity move? No effect. Okay, sure. Then I'm just going to remove this, and then just don't have to. Sure. Yeah, so it's a struct and it doesn't need to be moved. It's trivially copyable. So I think, yeah, we should be fine now. This should be a really simple arena. So let's test the arena separately. So let's just always run our tests and then create a core arena, which should be in scope since we import regex parser here. So let's see what it actually does. Just constructing it. So constructing it allocates a new list with space for 16 elements. Yeah, it didn't allocate a thing. So yeah. It allocated a pointer, but the internal pointer, it is not initialized, so it points to garbage. So then we put a block there, and then it actually points to valid memory. So okay, so this worked. So then let's allocate like 555 bytes, and let's try what happens. Let's see what happens. So if you would like to allocate, size is less than our max size. So we skip the first block. Capacity. So I think we should skip this. Crash. So why did we crash? Now it doesn't crash. So now it didn't crash. I think something was fishy. So then we have a current block, points to memory. We remember the pointer. Yeah, and of course it points to garbage. Then we advance the size. So in the next time we will allocate, we subtract size from capacity. So I think it should work and return our pointer. So then we can use it to allocate something else. So let's do a big allocation. Should be fine. So in this case, I see what the problem is. So in this case, we're just leaking one block, but this should not really be a problem. So we already allocated this first block. In this case, we're just going to create a new block with this size. Actually use this size. Yeah. We're adding it to our list, just return its memory. So in this case, we leaked our internal block. So, and if we then would allocate again, for example, a much smaller memory, let's do it. So now we allocate a smaller chunk. Now we would have to allocate again, since the last block is the big block, and this is already filled. So we push a new block, then the last block have enough space to hold like 5 bytes. Yeah, 5 bytes. So I think this should work. Of course, if we create a breakpoint here, we're just going to free. In this case, we have 3 blocks, and we're just going to free every block. So I think our arena should work. And if not, we will fix it later. It looks okay. Yeah, so I didn't add this file. Introduce class core arena, a simple bump allocator. So, but it is not global, it is in a class, so I can create more of them and use different threads. Each thread can theoretically use a custom arena, so I use a class to manage it. Of course, I should have said this sort of this. So in this case, of course, we're just using the arena in our regex parser so that we don't leak memory there. So this should be a good last commit for now. So the test using the arena, and of course we're using it here too. So let's see. Use core arena to allocate AST node regex AST nodes. Regex AST nodes in regex parser. Okay, sure. So this should be it. Now, video we achieved quite some things. I think so, at least. So we added character classes to our regex parser, and we made sure that the regex parser changed our regex parser to not allocate every instance on the heap, but use a little arena helper class which just allocates out of basically a pointer. It just bumps the pointer and it allocates big chunks and gives out small chunks whenever you request memory. So we're just doing this not to make something fast here. The first draft we want to express something like this. We would like to create an arena, such as our test code. We would like to create an instance of a parser, give it the arena, then call parse, which just allocates out of the arena many allocations, potentially many allocations, then consumes the trees, such as here, if we have an error, we print the error, else we use the tree to construct a string. Then we want to drop every instance, every yeah, every instance of the tree on the floor at once. And this is what this arena we are using here. So I think we're going to basically very similar need this in our main code, but today we're only using it in our test code, and everything works as intended. So I'm just going to rerun our program one last time. Exit code 0. No test fails. Just change something and see if it actually still can fail. So it still can fail. In this case, yeah, I've changed this code to this. So in this expression gets printed really horrible, but I think this is not my problem. This is the way the compiler. So this expression evaluates to this. There's a cat again in front of my screen. I don't see anything. So please wait. You get your food in like 5 minutes. So and of course I broke the test. So just to make sure. Oh, works again. Perfect. So then that's all I wanted to achieve today. I thank you for watching. Have a great day. See you next time. Bye.